the angle, which they're doing right here. Values of theta. This means you're going to have to use the second button because you're undoing the cosine. Or in other words, you're doing second cosine to find it. Okay? Now, if you go and you do this, notice how on the right-hand side here, I have instructions highlighted in yellow. It says theta is between 0 and 360 inclusive. That means it wants your answer in degrees. It tells you, give me the answer in degrees. Okay? So make sure you're in degrees right now. It also tells me to give the answer to 2 decimal places. Make sure you read directions on a test. That's why some people lose points. Read the directions. So second cosine and what do you get?
46.
Okay, slow down. Second cosine of 0.6820 equals 47.9999. It keeps on going.
9987152.
Okay, I need one person because it's really confusing when there's a cacophony of information coming at me. Joe.
46.999875152.
Did you say 46 or 47 point?
46.
So it's 47 degrees.
Oh,
it's 48.
No.
Stop talking. There's something wrong. Where is the cosine positive? Gannon. Sorry, that's only half correct. Joe Nelson.
And 1.
Sorry, 1 is half correct. That's not good. Anna. 1 and 4 is correct. The cosine is positive here and here. The reason I'm telling you that is you saw that the cosine was positive 0.6820. That means that there's 2 answers. You found the answer that was right here. This was the 47 degree angle. But the other one that you want is the angle that's in the 4th quadrant that has a reference angle of 47 degrees. That means you're looking for this one. The pink angle. And if you're in the 4th quadrant, you take 360 minus 47, which means you're also looking for 313 degrees. So there are 2 answers, 47 degrees and 313 degrees. You have to have both to get full credit. So in this next one, we know that the sine is positive in 2 quadrants. Quadrant 1, quadrant 2. So the first angle, when I do second sine, I end up with 52 degrees.
Very nice.
So that means I'm right here at 52 degrees. So that's one of my answers. And that's fine. Except we also know that there's supposed to be another measurement that's in the next quadrant. So if I'm looking for that next measurement in quadrant 2, that means its reference angle has to be 52 degrees, or in other words, this is 52 degrees. That's not the angle I'm looking for, though. I'm looking for the other one, because the 52 is the reference. So the answer I want is going to be 180 minus the 52, which is 128. So my answers are 52 degrees and 128 degrees, because these are the 2 angles that have a sine of 0.7880. In the final example, same thing, tangent. Tangent is positive, in the first quadrant, because everything's positive there, and in the third quadrant. And when I find the degree measurement in the first quadrant, I find out it's 41 degrees. Is that correct?
Yeah.
So 41 degrees right here in the first quadrant. So that's one of my answers. But since I know that there's another one in the third quadrant, I have to draw another angle measurement that goes all the way around to the third quadrant. And its reference angle is 41 degrees, or in other words, between the terminal side and the x-axis. It's always to the x-axis. So this means I have 180 plus that 41, which is 221 degrees. So 221 and 41 are your two answers for the last one. So it's always about the reference angle too. So these last two problems I'm going to set up for you, but I'm not going to finish. I want to set them up because I think it's kind of tricky the way they word them. And what I mean by that is whenever you see these things with cosecant equals whatever, what they're talking about is that triangle stuff that we've been doing. But what I want you to know, and the thing that's kind of maybe tricky, is that cosecant, remember, is 1 over the sine. I want you to keep that in mind. So when I draw my triangle, they tell me I'm in quadrant 4. So I draw my triangle in quadrant 4. Here it is. And they tell me the cosecant is -2. If I write down cosecant of an angle equals -2, but instead I write it as a fraction, that's implying that my sine of that angle is -1/2. Very good, Joe. -1/2. Now I can go over to my triangle and go, oh, sine, opposite over hypotenuse. And now I can answer the questions. So the thing I want you to know is whenever they give you something that's not sine or cosine or tangent, find the sine, cosine, or tangent first. And then you can lay out the triangle the way you want to. That's what I wanted you to know about these two problems. So in the last one, same kind of situation, they give us secant. And we know that secant is really the same thing as 1 over the cosine. So if I tell you that your secant is 9/4 negative, that means that my cosine of that very same angle is going to be -4/9. I just flip it, because they're reciprocals of each other. So now that when I draw my triangle, they tell me I'm in quadrant 3. So I draw my triangle in quadrant 3. And when I draw that, the cosine, which is the adjacent over the hypotenuse, is -4 and -9. And now I can set up and do the rest of my problem. So I'm just going to babble on right now in the last problem to do this one. It says find the tangent. In order to find the tangent, I have to use the Pythagorean theorem. So 81 minus 16 is 65. So this last side is the square root of 65. And if I want the tangent, I know the tangent is the, oh, this is negative, right? Because it's in the third quadrant. It's below the x-axis. So if I want the tangent, I would have the opposite, which is -√65, over the adjacent, which is -4. And then I would simplify that into just radical 65/4. So this is my final answer. The key, again, to this problem was understanding that when they give you a trig thing that you might not be familiar with, change it to sine or cosine or tangent, which you are familiar with. In the previous example, if you were doing that one and you wanted to solve it, I know that if I do the Pythagorean theorem, 2 squared is 4, minus 1 is 3. So this is really like the square root of 3 here. And then if I want the cotangent, cotangent is the same as the, instead of the opposite over the adjacent, it's the adjacent over the opposite. Right? So the adjacent over the opposite is √3 over -1, or in other words, -√3.